Hi, today we're going to learn what build automation is and its importance, what Gradle is, and the way it builds the configuration through a directed acyclic graph. Plus, we're going to generate a Java application using Gradle's convention. Build automation is the process of automating the creation of a software build and the associated processes, including compiling computer source code into binary code, packaging binary code, and running automated tests. In software development process, once a product requirement has been defined, designed, and ready to be implemented, the developer can start implementing the feature or requirement through writing the code. He then compiles it to produce the binary source and verify if the code is working fine through running a bunch of tests. If the test fails, he fixes the code, compile, and run it again. Once he's happy with it, he needs to package it, deploy to an environment where QA or end users could test out the feature. All these steps can be automated by a build automation tool like Gradle. Gradle is an open source build automation tool focused on flexibility and performance. Gradle build scripts are written using a Groovy or Kotlin DSL. Gradle is modeled in a way that is customizable and extensible in the most fundamental ways. Gradle completes tasks quickly by reusing outputs from previous executions, processing only inputs that change, and executing tasks in parallel. Gradle is the official build tool for Android and comes with support for many popular languages and technologies like Java, C++, Groovy, Scala, and the like. Gradle models its builds as directed acyclic graphs of tasks. What this means is that a build essentially configures a set of tasks and wires them together based on their dependencies to create that DAG. Once the task graph has been created, Gradle determines which tasks need to be run in which order and then proceeds to execute them. Now let's generate a Java application using Gradle init command. If you want to follow along, you will need a text editor like IntelliJ IDEA, a Java Development Kit version 8 or higher, and the latest Gradle distribution. Let's create a project folder. Gradle comes with a built-in task called init. That initializes a new Gradle project in an empty folder. The init task uses the also built-in wrapper task to create a Gradle wrapper script Gradle W. When prompted, select application project type, Java as implementation language, Groovy as the DSL, and for other questions, press enter to use the default values. The init task generates the new project with the following structure: generated folder for wrapper files, Gradle wrapper start scripts, settings file to define build name and subprojects, build script of app project, default Java source folder, and default Java test source folder. You now have the project set up to build a Java application. Let's review the project files. Settings.gradle has two interesting lines. Root project.name assigns a name to the build, which overrides the default behavior of naming the build after the directory it's in. It's recommended to set a fixed name as the folder might change if the project is shared. Include app defines the build consists of one subproject called app. That contains the actual code and build logic. More subprojects can be added by additional include statements. Our build contains one subproject called app that represents the Java application we are building. It is configured in the app/build.gradle file. Comment has been added to explain the use of each line. Here's our main class that will return the hello world greeting. The generated test class has a single JUnit Jupyter test. The test instantiates the app class, invokes a method on it, and checks that it returns the expected value. Thanks to the application plugin, you can run the application directly from the command line. The run task tells Gradle to execute the main method in the class assigned to the main class property. The application plugin also bundles the application with all its dependencies for you. The archive will also contain a script to start the application with a single command. After running the full build, Gradle will have produced the archive in two formats under the distributions folder. The following files, which are the app.tar and the app.zip. That's it! You've now successfully configured and built a Java application project with Gradle. You've learned how to initialize a project that produces a Java application, execute a Java application using the run task from the application plugin, bundle the application in an archive, and know what build automation tool is and how it helps with software development. You also know about the directed acyclic graph that Gradle depends on when configuring its build script. Thank you for watching this video. If you haven't subscribed yet, please click the subscribe button to notify you in the next tutorial. See you in the next video, and as always, happy coding!